In this video, we're going to apply the midpoint rule with n equals 4 rectangles to estimate the area under f of x equals x squared plus 1 and above the x-axis from 0 to 2, that is x between 0 and 2. The key concept here is that the area of a rectangle is length times width. The length is given by the function f of x, and the width is given by delta x. And we're basically adding up rectangles. But the key point is that we're evaluating the function at the midpoints, at x equals 1/4, at x equals 3/4, at x equals 5/4, and at x equals 7/4. All right, we have n equals 4 rectangles, and delta x, the width, is going to be 2 minus 0 divided by 4. We have equal width, that's 1/2. The important thing to remember is we need to find the midpoints of every interval. For example, for the first interval, x is equal to 0 plus 1/2 divided by 2. That's equal to 1/4. And for the last interval, x is equal to 3/2 plus 2 divided by 2. That's equal to 7/4. All right, let's make a table of values. We have x, f of x is equal to x squared plus 1, and we have our delta x, that's the width. When x is 1/4, the height of the function, f of 1/4, we plug in x equals 1/4 into the function. That gives us 1/4 squared plus 1. That's 17/16. And we change that into a decimal. That's 1.0625. And delta x, the width, is always 1/2. And for the next x value, 3/4, let's plug in 3/4 into the function. F of 3/4, that's equal to 3/4. All squared plus 1, and that works out to 25/16. Change that to a decimal, and we get 1.5625. Delta x is again 1/2. Now, let's evaluate the function at x is equal to 5/4. F of 5/4, the functional value, the height of the rectangle, is given by 5/4 squared plus 1. That works out to 41/16. Change that to a decimal, that is 2.5625, and delta x is again 1/2. And the last x value, x is 7/4. Plug that into the function to get the height. F of 7/4 is equal to 7/4 all squared plus 1. Let's add it up. That gives us 65/16 as a fraction. Change that to a decimal. That is 4.0625. And the width again is, of course, 1/2. All right. For the midpoint rule, we evaluate the function at the midpoint of every rectangle. So the area is going to be equal to, approximately equal to, f of 1/4, the height of the first rectangle, times the width, 1/2, plus f of 3/4 times 1/2, plus f of 5/4 times 1/2, plus f of 7/4 times 1/2. Let's factor out the 1/2. So 1/2 times f of 1/4 plus f of 3/4 plus f of 5/4 plus f of 7/4. But these functional values have all been calculated in the previous page. On page 2, you will see that we calculated all those functional values. So let's just plug those in. The area is approximately equal to 1/2 times f of 1/4, that's 1.0625, plus f of 3/4, that was found to be 1.5625, plus f of 5/4, that is 2.5625, plus f of 7/4, that's 4.0625. Let's add up all these numbers, and we get 1/2 times 9.25. That's equal to 4.625. So we've approximated the area below the function f of x equals x squared plus 1 and above the x-axis to be 4.625, applying the midpoint rule with n equals 4 rectangles. If we go back to the drawing on page 1, you will see that the midpoint rule is actually better than the right-hand rule or the left-hand rule, because the part of a rectangle that's above the curve balances out the part of the rectangle that's below the curve. So it is a better estimate of the area under the curve. All right, thanks.